Section 6.1 is going to be an introduction to algebra. So we're going to talk about order of operations and solving equations. So if you've had any algebra courses over the years, hopefully this should be review. First, just some general terminology. Algebra is just a generalized form of arithmetic. In algebra, you're going to run into variables. Variables are just letters that are used to represent a number. You do not know the value of the number, so that's why we use a letter. A constant is going to be a symbol that represents a specific quantity. Typically, constants are going to look just like plain old numbers. An algebraic expression is a collection of variables, numbers, parentheses, and operation symbols. All of these down here are examples of expressions. Notice there's plus signs, minus signs, exponents, division, parentheses. But notice there's no equal sign. Expressions are not equations. Expressions are just groups of terms. Terms are the parts that are added together or subtracted in an expression. So if you looked at 4x minus 3y minus 5, you would say that this has three terms. 4x is one, minus 3y is the second, and minus 5 is the third. Now, if you look at the 4x and the minus 3y, they have letters and numbers. The number part is called the coefficient. So on the first term, on the 4x, the 4 is the coefficient, and on the minus 3y, the minus 3 is the coefficient. The minus 5 doesn't have a letter. It's called a constant. One thing that's important is that you know what a like term is. Like terms are going to be terms that have the same letter with the same exponents. If they have different letters or different exponents, they are going to be considered unlike terms. This is important because often you'll be asked to combine like terms, so only things that have the same letter with the same exponent can be combined. To simplify an expression, that is the same thing as combining like terms. And you want to make sure that there's no parentheses left and that all the like terms have been combined in order for something to be completely simplified. In order to simplify, there's several properties that we're going to use. One of the first properties we'll use is the distributive property. And you'll typically know when you want to distribute because there'll be a number sitting on the outside of a set of parentheses. And all you need to do to clear the parentheses is to multiply each number within, and that will make the parentheses go away. You can also use the commutative property of addition. All that says is that it does not matter what order you complete the addition in. There's the commutative property of multiplication. Again, order does not matter. You can complete multiplication in any order you want. There's the associative property of addition. All that says is you can group addition terms in different ways, and you'll end up getting the same answer. And last is the associate property of multiplication. Again, the groupings within multiplication is not going to affect the value of the answer. So for example, if I showed you the expression 3x plus 6x and I asked you to combine like terms, you would verify that they're both using the same letter, they are both using x's, and that the exponent on the letter is the same. Both of these x's have a power of 1 on them. They don't show you the power, but there is little pretend 1s up here in the exponent spot. Mathematicians don't write that because they consider it redundant. So if you ever see just an x with no exponent on it, the power is 1. So if you have two items that have the same letter with the same power, you can take their coefficients in the front and add them together. So simplified, this would be 9x. Often you'll be asked to evaluate an expression. When you evaluate an expression, you're trying to find the value of the expression when a given value for the letter has been told to you. So when you evaluate an expression, you want to make sure you do the order of operations in the proper order. First thing you want to do is do anything that's in a parenthesis or a grouping symbol. So grouping symbols can be parentheses, brackets, absolute value bars. You can even consider division as a grouping symbol where the numerator is a group and the denominator is a group. Once you've done everything in the grouping symbols, next you want to perform the exponentials. Now exponentials can be powers, they can also be roots. So a square root of 4 is considered an exponential, so you would want to simplify that to be 2. After all your groups have been simplified and all your powers have been simplified, then you'll do multiplication and division. Now you don't always do multiplication first. You do them in the order from left to right. So if division just happens to be the first one that's on the left, you would do the division first. After all the multiplication and division is done, then you do addition and subtraction in the same way, from the left to the right. So let's say I gave you the expression negative x squared plus 3x plus 10. And I asked you to evaluate it when x is 2. So what that means to do is to replace all the x's in the problem with the number 2. I like to put the item that's being plugged in parentheses. Often if you do not put it in parentheses, you will get the answer incorrect. Okay, so substitute the problem in first, the letter in first. Then you want to look for grouping symbols. Well, I do have 2 grouping symbols. I have a set of parentheses in 2 locations, but there's nothing inside of the grouping symbols that I can simplify. So I need to move on to exponents next. There is one exponent in this problem. You have 2 being raised to the second power. Notice I did not include the negative as part of that. The negative is separate. So the negative is going to hang out while you take 2 and raise it to the second power. 2 to the second power is 4. Then you will complete multiplication and division from left to right. So I have my 3 times 2, which is going to be 6. And then last, addition and subtraction from left to right. So you'll first add the negative 4 plus 6, which is 2. And then 2 plus 10 would give you 12. So now that you can simplify algebraic expressions, we're going to start joining 2 expressions together and turning them into equations. So notice equations will always have equal signs with an algebraic expression on the left and on the right-hand side. These are called equations. Often you're going to be asked to find the solution of an equation. The solution of an equation is the number that you use for x that's going to make the left-hand and the right-hand side equal. So for example, if you looked at this first equation, what number plus 2 would equal 4? Well, you would have to use the number 2. So if I asked you what the solution was of the first equation, you would say 2. The process of finding the solution is called solving. So if you're ever asked to solve an equation, they just want to know what value of x would make the equation true. Often, after you find a solution, it's a good idea to check the answer. To check the answer, all you have to do is substitute the number in for the letter, or evaluate it, and make sure that the right-hand side and the left-hand side equal. If they do, this is called true. If the right-hand side and the left-hand side don't equal, it's called false and your solution's not right. So for example, if I gave you x plus 3 equals 4, and someone said they thought the solution was 1, they would replace the x with 1, they would simplify the left-hand side and verify that the left-hand side and the right-hand side are equal. So this is a true statement, so that means 1 is a solution. So for example, 3x squared plus 7x minus 11 equals 15. I would like to determine if 2 is a solution of this. So anywhere I see an x in the problem, I'm going to replace it with the number 2. And I'm going to simplify the left-hand side. So I would look for grouping symbols first. I do have grouping symbols with a 2 inside, but I can't simplify 2 any further. So then I would look for exponents. 2 to the second power would be 4. Then I look for multiplication and division. 3 times 4 is 12, and 7 times 2 is 14. And then I complete addition and subtraction. 12 plus 14 is 26. And 26 minus 11 is 15. And notice that 15 does equal 15, which is a true statement. So the number 2 is a solution to this problem. We're going to start solving equations, and we're going to focus on linear equations, which means that you'll only have one variable and that the variable will only have an exponent of 1. If you ever notice that two equations have the same solution, those are going to be called equivalent equations. So to solve any equation, what you want to do is you want to isolate the variable on one side. So in general, when you look at the equal sign, you want the variable to be on one side of the equal sign all by itself. There are 4 properties you can use in order to do that. The first property is the addition property. All this says is that as long as you add the same number to the left and the right, the equation will stay balanced. So let's look at an example. I have the equation x minus 8 equals 12. And I really want to get the x alone, but there's a minus 8 on that side with it. So what I need to do is I need to do the opposite of minus 8 to make it cancel. As long as I do that to both sides, my equation will stay balanced. And in this problem, x is 20. Then if you want to check your answer, you just plug it in. Is 20 minus 8 equal to 12? It is. So you have a good solution. The second property is the subtraction property. And the subtraction property says you can subtract the same number from both the left and the right-hand side of the equation, and the equation will stay balanced. So if I was trying to solve the equation x plus 11 equals 19, the opposite of a plus 11 is a minus 11. And as long as I do that to both sides, I can get my x isolated, and x is 8. Then you can check your answer. 8 plus 11 is 19. The third property is the multiplication property. You are allowed to multiply both sides of the equation by the same number, and the equation will stay balanced. You don't really want to multiply by 0 though, because that's just going to zero out both sides. You won't make any progress for finding x. So if I was trying to solve the equation x divided by 4 equals 8, a lot of times people get nervous when they see that because they think it's a fraction. Just treat it like it's division. The opposite of dividing by 4 is multiplying by 4. And as long as you do that to both sides, it will eliminate the 4's and your x will be alone, and your x is 32. Then of course check your answer. Is 32 divided by 4 equal to 8? The last property of equality is the division property. So this says that you are allowed to divide each side of the equation by the same number. The number is not allowed to be 0 though. As long as it's the same number, the equation will stay balanced. So if I was trying to solve the equation 7x equals 35, my x is being multiplied by 7. The opposite of multiplication is division. So I would divide each side of the equation by 7, which would isolate the x and tell me the solution is 5. So the general procedure for solving a linear equation. First thing you want to do is you want to see if there's any fractions. If there are fractions, you want to multiply both sides of the equation by the least common denominator. This will eliminate all the fractions and make your life a lot easier. I'll show you how to do one of these in a second. After the fractions are eliminated, you want to use the distributive property to remove any parentheses. Parentheses in solving are bad. After the parentheses are gone, you will combine like terms on each side of the equal sign if possible. Sometimes it's not possible. After the parentheses are gone and you've combined the like terms, you will do the addition or subtraction property first. That will allow all of the items with x's to be on a side by itself. Notice you may still have a number in front of the x. That's what the last step's for. Last step, you will solve for the variable by using the division or the multiplication property so that the variable is on one side alone and there's a constant on the other side. After you find out what the variable is equal to, I recommend checking your answer so that you can make sure you have the proper solution. So this is called a two-step equation. 3x minus 5 equals 28. So if you go through all your steps, you would first look for fractions, which you don't have. You would then look for parentheses, which you don't have. You would then combine like terms on each side, which you don't have. Then use your addition or subtraction property. Since you have a minus 5, you would eliminate that by adding 5 to both sides. This would leave the 3x on the left-hand side and a 33 on the right-hand side. Next, you need to get the x alone by getting rid of the 3. Because the 3 is multiplying the x, you can undo this by dividing both sides by 3, and x is 11. If you want to check your answer, substitute it back into the original equation. 3 times 11 is 33, and 33 minus 5 is 28. So this is a good solution. Let's take it up a step. So you have 6t plus 11 equals 2 times the quantity, t plus 6 minus 5. So if you're doing your 5-step procedure, you would first look for fractions, which you do not have. Then you would look for parentheses. Parentheses are bad, so we would need to eliminate the parentheses by using the distributive property, which just means you multiply each number inside the parentheses by what's on the outside. Notice I did not multiply the minus 5 because it is not in the parentheses. Then you look at each side of the equation to see if there's any like terms that can combine. On the right-hand side, you can combine the 12 and the minus 5, which will make 7. Then in general, you want to try to get all the variables to one side. So I'm going to move the 2t with subtraction. Then I'm going to move the 11 with subtraction. And then last, I'll get rid of the 4 with division. So your t should be -1. And then again, I would recommend substituting that back into the original equation to check your answer. Problems with fractions tend to be everyone's least favorite. So let's say I gave you the following. 2x over 3 plus 1 over 3 equals 3 over 4. And I asked you to solve. Typically what I like to do is I like to eliminate the fractions. So you want to look at the two denominators, well, 3 denominators. In the denominators you have the number 3 and you have the number 4. And you want to find what would be a good least common multiple or least common denominator. So what number do 3 and 4 both go into nicely? Well, they both go into 12 nicely. So then what you would do is you would go to each side of the equation and you would multiply through by 12. So if you're not good at fractions, that's totally fine. You can absolutely do this in your calculator, and I can show you how to do that. I'll give you a little video here. Okay, so I'm going to do the 12 times the 2/3. And so all you have to do is type in your 12, type in your times, and then in parentheses put 2 divided by 3. And that'll give you your 2/3. Hit your enter and you get an 8. So when I take 12 times 2/3, I'm going to have an 8x. Now I'll do the same thing for 12 times 1/3, which is going to give me 4. And then I'm going to take 12 times 3/4, which is going to give me 9. Then you don't have fractions anymore, so solving should be pretty straightforward. Subtract your 4. And last, you'll want to divide by your 8. Now, don't let this panic you. It doesn't divide out evenly. Just leave it as a fraction 5/8. Okay. Sometimes when you go to solve an equation, you will run into a situation where there is no solution. And what that's going to look like is it's going to look like two numbers that are left that are not equal to each other. So I have an example of that here for you. Let me show you what it looks like when you go to solve this. So the equation is 3 times the quantity x minus 5 plus x plus 12 equals 6x minus 2 times the quantity x plus 2. So the first thing you would do here is distribute your 3 and distribute your minus 2. Be careful when you distribute a negative number because it will change the signs of both items in the parentheses. And then you want to combine like terms on each side of the equal sign. So on the left-hand side, I have a 3x plus a 1x, which is a 4x. Notice even though they don't write a 1 in front of that x, you read it as 1x. I have a minus 15 and a positive 12, which is a minus 3. On the right-hand side, I have a 6x minus 2x, which is 4x, and then a minus 4. Many people can tell right here that this is not going to have any solutions because the left-hand side and the right-hand side will never equal each other. But if you want to keep going and try to collect the x's on one side, you're going to notice that all the x's end up eliminate, and you're left with two numbers that do not equal each other. That's not allowed. And so if you ever run into that situation, that means there's no solution. All that means is there's never a time when the right-hand side and the left-hand side will ever equal each other. You can also have a situation where there's infinitely many solutions. So if you have the equation 2 times the quantity x plus 4 minus 3 times the quantity x minus 5 equals negative x plus 23. Again, first thing you want to do is clear your parentheses. So that'll turn that into 2x plus 8 minus 3x plus 15 equals negative x plus 23. Then you'll want to combine like terms on each side. So on the left-hand side, we have 2x minus 3x, which is negative 1x, positive 8 and positive 15, which is positive 23. And if you notice here, the left-hand side and the right-hand side are identical. You could stop there and say that there's infinite solutions, but if you wanted to keep going and collect your x's together, you would notice that they both eliminate, and you're left with two numbers that do equal each other. That just means there is an infinite number of solutions. Any number in the world that you substitute in for x will work. This does have a special name. An equation of this type is going to be called an identity. So the solution to any linear equation with one variable that is an identity is called all real numbers. Any real number will work.